Another variation of our permutation formula that we need to consider regards permutations of duplicate items. To help you understand what is meant by duplicate items, let's begin with an example. Example 6, list the permutations of 911. Now remember, think about the word permutations as arrangements. How many different ways can we arrange the numbers in 911? Now, with a permutation, the order makes a difference. So when I rearrange those numbers, I get a different number. For example, if I'm trying to dial 911 and I type it in as 119, it's the wrong number, right? So the order in which those items appear are important. Now, one permutation of those numbers is, of course, 911. Now, since these two numbers are the same, let's suppose I switch those. Well, it doesn't make anything new, right? So I'm not going to be able to rearrange those last two items like we did back here on example 2. Remember, we were listing the permutations of the letters M-A-T-H, and we found when we switch those last two spots, we get a new word. Well, that's not going to work in the case of this example because those are duplicate items. So another possible permutation would be 191 and 119. And those are the only possible permutations of 911. So we can count the number of arrangements or permutations of items even if there are duplicate items using our factorial formula. It works like this. The number of permutations or arrangements of n items, so that's the total number of items that I have, where P items are identical, Q items are identical, R items are identical, so on and so forth, is given by n factorial, so the total on top, divided by, and this is going to count the repetitions of individual items. And this can be continued for any number of repeated items that you have. So to make this formula clear, let's apply it to our previous example. Use the formula to count, not list, but count the number of permutations of 911 as discovered in example 6. Now we know it should come out to be 3, right? Because we had 3 different permutations that we discovered. So to use this formula, we're going to observe, first of all, we have a total of 3 spots. So the top number is the factorial of the total number of items that you have. Then I'm going to look at each individual item. The 9 does not repeat, so I don't have to cancel anything with that one, but the 1 repeats twice. So I'm going to say, since it repeats twice, I'm going to divide by 2 factorial. When we expand our factorials, 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. Then we can cancel like factors, and we obtain our expected result. 3 permutations, and that's what we ended up with up here. This is a very simple example because we have a small number of repeated items. So you may be thinking, well, I'm just going to rearrange them and count them. But if you get a lot of repeated items, then you'll definitely need the formula. So here's an example. How many permutations are possible with the letters of your name? So here's my full name, Shannon Elaine Cornell. You can either follow along with my example, or you can write down your name. Write down your first, middle, and last name and count how many different ways can you rearrange the letters in your name, right? So I'm going to start with the total number of letters in my name. If you take the time to count all of those letters, there's a total of 20 letters. So in the numerator, we're going to do 20 factorial. Then I'm going to look for repeated items. S only repeats once, so I don't have to count that in the denominator. H, there's only one H, so I don't have to worry about that one. But as far as A goes, I've got 1, 2 A's. Since A repeats twice, I'm going to put a 2 factorial in the denominator. Now I've got quite a few N's. I've got 1, 2, 3, 4, 5 N's. Since N repeats 5 times, I'm going to divide by 5 factorial. As far as O's go, there's an O that repeats twice, so I need another 2 factorial. I have 1, 2, 3 E's, so I need a 3 factorial there. There are 1, 2, 3 L's, 3 factorial there. There's only 1 I, so I don't have to worry about that. 1 C and 1 R. Now I have to be very careful when I plug this into my calculator. I want to make sure that the calculator does the correct order of operations. So that means I'm going to need to put this operation in the denominator in a set of parentheses. So when I evaluate this, I'm going to have 20 factorial on the top. Remember, factorial is option number 4. Then I'm going to divide by and keep this entire denominator in a set of parentheses. 2 factorial. I don't have to type the multiply button. I can imply multiplication simply by typing in the next number there. So I can write the 2 factorial right next to the 5 factorial. And the same thing will be true for the rest of the factorials. One way to think about this problem, we are counting the total number of ways, we are counting the total number of ways you can misspell your name, right? Well, 1 will be the correct spelling. All the other permutations will be the incorrect spelling. So there we have it all typed in. When we press enter, we end up, for my particular name, it puts it in scientific notation. That means it's a very large number, 1.41 approximately. E14, that means times 10 to the 14th. So 1.41 times 10 to the 14th power. And again, that means I'm going to take the decimal from its current position. And this is approximate since I rounded it. I'm going to take it from its current position and move it 14 places to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if we add our commas here, there's the thousands, millions, billions, 141 trillion. So because I rounded it, we can say over 141 trillion different ways to rearrange the items in my name. And keep in mind, because some of those were repeated letters, these values in the denominator are serving to cancel out permutations where I'm just switching the position of 2 N's, for example, where you can't observe a different permutation. So that finishes our section on permutations. Remember, a permutation is used when we're selecting more than one item per category, and the order is important. And then we have a special distinct formula for calculating the number of permutations when some of those items are repeated. And again, practice with your calculator and let me know when you have questions.